Okay, good day everyone. So since I cannot make it today for the video live streaming, so I already downloaded or recorded a video for our class discussion today. So as you notice, it's already available via YouTube, and as you see, you can see the link now in the LMS for the link of the video. So this time we will just continue with our discussion about our discussion. We finished already the operations of fractions such as multiplication, division, order of operation, together with addition and subtraction of fraction. Now this time, our new topic that we are going to discuss is about decimals. I'm pretty sure you have already idea as to what decimal is, right? So I'm sure you've heard already what decimal. Decimal is the very common term that we know, but actually it's known as decimal notation. Okay, because it's actually a mathematical expression that involves decimal. Okay, so thus there is an inclusion of whole number, the decimal part, and then the decimal point. So if I'm gonna write it, example, well, this is very common, or decimal is very common among very common in, say for example, for prices, okay, in supermarket when you look for a price tag, so you will always encounter decimal notation. So let's say for example, we will buy or we will you will do purchase in a super mall or convenience store, and then you will say a price of, example, 221.75 pesos. So you notice here, if I'm going to emphasize this part, of course the peso sign here is our symbol. This part is this is called as a whole as decimal notation. Okay, it's called the decimal notation. With this one here is our decimal part, and this is the whole number part. Okay, the whole number, or the whole number part. And then of course, you can see here the dot here, it's called the decimal point. Because what makes this decimal notation is, of course, there should be a decimal point. So we have the decimal point, the whole number part, and then the decimal part. Okay, that I think that is just to revisit what decimal notation is. Now, this time, we will just get to know more about decimal. Then we will, as we progress with our discussion, we will talk about operations of decimal. But for the meantime, let's just talk about for some of the terms or topics that we will encounter when we talk about decimal notation. So let me just erase first this one. Okay, let me fix first this. Okay, so we will start with um, identifying place value for a decimal notation. So how do we identify place value? We did already the identification of decimal notation before. Not decimal notation, but rather for whole number. So this time, what we're going to do is we will identify places of value for decimal notation. Let's say for example, we have a decimal notation of, okay, our example earlier, 21.75. So we will just take away first the symbol. Let's just consider first the number. So we have here the decimal notation of 21.75. Now let's try to identify place of value. Now, of course, for the whole number part, as we discussed last time, this is the ones place, okay, ones. Then this is the tens. And then as we move further, that's hundreds, thousands, 10,000s, 100,000s, and million, so on and so forth. Now, our focus is the decimal part. Okay, the decimal part actually is the number that is after the decimal point from the left. So from left to right, the numbers after the decimal point is our decimal numbers, or the decimal part of the decimal notation, also known as the um, the decimal numbers. Okay, so we will identify. In fact, when you have a decimal notation, the decimal digits, okay, that's what I'm thinking about to say. The decimal digits do not actually start with ones. Okay, there's no ones place. Remember, decimal occurs only because a decimal value is expressed or can be expressed in fraction form. Okay, fraction part. And then fraction part will only take place starting with two decimal places in the denominator. Because if it's ones place, then that means to say it is 1. Okay, so let's identify. So what I'm saying here is that there is no ones place in the decimal digits or in the decimal part of our decimal notation. So what do we have here? The place value for the decimal digits or digits starts with the tens place. But instead of writing it as tens like this one, it is written as tens like this. Tens. I don't know how to pronounce it well, but tens. And then followed by the hundreds. Hundreds. So you notice there is addition of the THS. That is the thing to distinguish now between the decimal part and then the whole number part. Okay, because we have here the ones place and tens place. This is so because this is referring to actually places of value. So we'll start with the tens place. There's no ones place. You know why? Because for example, for the purpose of discussion, 0.75 is expressed or equivalent to 75 over 100. That's why this is still the hundreds place. Hundreds. Okay, hundreds place. So a decimal part can be expressed as in fractional form. In fact, that is the other way of rewriting fraction. It is written in decimal form or in decimal notation. So let's say for another, let's say for instance, let's have another example of 5.91. 5.91 here. So in this case, let's add more. 7, 9. Okay, 9 here, as you notice, this is written as, okay, tens, hundreds, thousand, 10,000. So that is 10 thousands. Thousands. With THS. Okay? That is to identify a place value. So we identify 9 here as in the 10,000s place. And then the 7 here is the thousands place. And then the hundreds place. And then tens place. Okay? That's how we identify the place of value for the decimal notation. So, let us write this decimal notation in word form. Remember, for whole number, there is standard form and there is a word form for our whole number. So there's also equivalent to that in decimal notation. So meaning to say, we're going to write this one in word, not in standard form, which we will use the Arabic, the Hindu-Arabic form of the numbers. So let's say, for example, this one. This is written, or the equivalent of this one in word is 5, and then, wait, we use the word end. That signifies, the end here signifies the decimal point. Meaning to say you have 5 and, so 5 and, the word that comes after are already the words equivalent to our decimal, the decimal parts of the decimal notation. So 5 and, we will just simply read this one the way it is, and then we will just later on identify the last place value here, the 9. So for example, that's 5 and 9, right? That's 90. 91. Okay, do not forget hyphen 91,000. Okay, there's no TH yet. The TH will only happen to the last place value of the decimal part. So that's 5 and 91,000. Sorry, it's not 91,000, but it's 9,000. My bad, really. That's 9,170. Okay, hyphenated 79. And then we identified the place value of 9 here. So this is tens, hundreds, thousands, 10,000. And then you will place here 10 thousands. Okay? So this one in word form is equivalent to, sorry, this is supposed to be word. 5 and 9,179 10,000s. This one. So if we will write this one in word form also, that's 21. And of course, the n here signifies the decimal point, and 75 hundredths. Hundredths. Okay? So that's how we write the decimal point. Okay? So let's try examples and how we're gonna do this. And then after that, we will move to the next part or part of the topic. Let's say, for example, let's have this 0, 9, 6, 8, 4, and then we have this 3, 7, 2.516. Number 1 and number 2. Okay, before I'm going to write the answer, I'll give you time. Let's say I'll just give you 3 minutes. Try to write your answer for this part. And then later, I'll reveal also what is supposed to be the answer. Okay? I'll just give you 3 minutes to try to solve or write these numbers, this decimal notation into word, the equivalent word form of this decimal notation. And then later on, we will answer it all together so that you'll know and see whether your answer is also correct. This is sort of practice. Okay, after 2 minutes, I'm gonna show the solution. Okay, go on. I'll be giving you much more time. Okay, 4 more minutes. Okay, last 2 more minutes. One last minute, and then I'm going to write the answer for this item. Okay, so I think we're good already. I'm gonna write now the answer, and I suppose you have also written down already on your scratch paper the word equivalent of this decimal notation here as our example. So let's start with the first one. Okay, this one in word form, it is equivalent to, of course, we don't have whole number part here because it's 0. Now, standard wise of writing it in standard form, when we have a decimal notation without whole number part, then it is represented by 0. Okay, that's the standard way of writing. We do not just simply leave it as dot and then number. Okay, that's not the default or the standard way of writing decimal notation. So when the decimal notation do not have whole number part, you just place the whole number part section with 0. Okay, so with this one, since there is no whole number part in this decimal notation, as we will write this one into word form, this is going to be 9. My marker is no longer working. 9,000. Okay, that's 9,600. 684. 1, 2, 3, 4. 10,000s. 10,000s. Okay, that is its equivalent, the equivalent word form of this word. Actually, this should be written as 10 with hyphen here. It's hyphenated for the 10,000s. Okay, you have here 9,684 10,000s. Now, for the second example, here, this is going to be, or the equivalent word for this one is 3 hundred 72, and of course the n here is equivalent to the decimal point, and 516 thousands. Sorry, it's not going to. Let's try to write it properly. Thousands. PH. Okay? So it's 372 and 516 thousands. Okay? Thousands with PH towards the end, THS. It's because that's signifying that we are now dealing with the hundreds place, or rather the decimal notation form. Okay? I think we're good already with writing the decimal notation into word form. So very quick, I'll give you also here two example, and then I would like you to identify some places of value. Let's say 45.687, and then number 2 is 907.1342. Okay, we know very well that the decimal notation happens when we try to perform division, and then the number in the denominator does not completely divides the numerator. That's why there is a decimal part where the decimal notation is born. Okay, so look at this example, number 3 and number 4. You have 45.6 687, and then number 4 is 907.1342. Now, very quick, I'm going to identify a number in the given, and then you tell me its place value. Okay? So, I would like you to tell me what is 4. In this example number 3, what is the place value of the number 4? Yes? Okay, the place value for 4 here, actually 4 here is whole number, which is in the hundreds place. hundreds. And then what about the number 8? 8 here as a place value is referring to the what? The 10,000s place, or rather the hundreds place. Hundreds. Okay? 8 is the hundreds place. Now what about here? The number 4. 4 is in, yes, we have tens, hundreds, thousands. So 4 is in the thousands place. And what about 1? 1 is in, and what's the place value of 1? It is in the tens place. Again, it's not, there's no ones, sorry, it should be TH. Okay, tens place. Okay, again, there is no ones in the decimal part. Okay, so for the decimal part, the place value starts with 10. It is so because equivalent to that one in fraction form, we're referring to the tens place because a decimal notation starts only when you have the denominator is considered 10. Okay, divided when we express decimal notation or decimal parts into fraction. Okay, because a fraction is happening because a number in the denominator does not completely divide the numerator. That's why it is written in fraction form. Thus, its counterpart of that one is already the decimal notation. So a fraction, its counterpart is a decimal notation. Okay, I think we're good already with this part. The identifying the places of value in a decimal notation match with identifying or writing the equivalent word for any decimal notation. Now, this time, we're going to practice with writing. Okay, we're going to write now mixed number, or not mixed number, rather, decimal numbers into fraction. Okay, writing decimal notation into fractions. Okay, let's say for example we have 0.289. Okay, 0.829 or 0.289. Okay, we know that we read this one as 0.0 and, or it is 289 ten thousandths. Or sorry, 289 ten thousandths. Yeah, correct. So 9 here is in the 10,000s, in the thousands place rather. So this 289 thousandths, tens, hundred thousandths. So again, let me clear that one and emphasize it. This one here is read as, or read as 289 thousandths. Thousands as in THS. Okay? So we are going to rewrite this decimal notation into fraction. Okay? It's it's equivalent in fraction form. Okay? You know here, the places of value here identify, example, how many places of value in the decimal part, or how many place value there is, or there are in the decimal part, is equivalent to the number of zeros in the denominator. So you get me? So, in this example, there are 3 numbers, 1, 2, 3. So, there are 3 zeros in the denominator, meaning to say until thousands place. So, this is going to be written in fraction form as 289 to be the numerator, and then the denominator is actually thousands, 1,000. Because remember, 9 here is in the thousands place. Thousands. Okay? So if we will write this one in word form, we know that this is 289,000. Okay? So since our decimal notation, the last place value here is in the thousands place, that's why this is its equivalent. And then once it's written in fraction form, the denominator is also in thousands. Okay? But you have to understand that if your answer is in this form, you try to reduce it as much as possible to the lowest term. Okay? That's I think that's the challenge. But anyway, that's not our goal in this part of the lesson. Our goal is just to rewrite decimal notation into fraction form. So this is at least its equivalent in fraction form. Okay? But supposedly this must be reduced to the lowest term as possible. But that's not our concern for the meantime. Let's just focus first our energy in trying to rewrite decimal notation into fraction form. Let's have two examples. Example 1 and example 2. Let's say you have 0.67 and then you have 55.608, for example. Okay, I'll give you 3 more minutes and then you try to do it on your own. Later, I'll try to reveal the answer of how you're going to write this one, or at least what is the answer here. So the goal here for this part of this exercises practice work is that you will rewrite this decimal notation into fraction form, and then this one here, the same thing also you will write is decimal notation, from decimal notation into fraction form. Let's see. Okay, I'll give you 2 more minutes. Okay, I think we're good. 2-3 minutes is very much. Too much for you to work with this one. Anyway, this is just a very simple exercise for you to do. So, let's identify now or write this one into fraction form. Since we have 2 place value here in the decimal part, then that means to say that refers to the number of zeros in the denominator once this is written in fraction form. So, copy the decimal numbers as the numerator, 67. And then since there are 2 places of value here in the decimal part, it is equivalent to 2 zeros also in the denominator. So this is going to be hundreds because 7 here is in the hundreds. So therefore, the denominator is also in 100. Then for this one, you notice that this one is, there's a whole number part. So you know that the whole number part is actually the, what do you call this one? This is mixed number if written in the in fraction form. So this is going to be 55 point, or sorry, say 55 and 608 over 1,000 because there are 3 places of value, so that's equivalent to 3 zeros. Now, I told you, you have to reduce things here as much as possible. Reduce it to the lowest term. So, if you try to reduce this one, look for any common factor. Example, this one, reduce this to the lowest term. Just try to remove the 2, I think. This is 500. 304 over 500. But this is still divisible by 2. So, it's going to be divided by 2, that is 152 over 250. Reduce it, that's going to be 76 over 125. I think that's the last answer. Correct. So this can be written as 55 and 76 over 125. More or less, if we try to reduce it to the lowest term. Okay? So, yeah. Anyway, that's not our goal. Our goal is just how what is its equivalent in fraction form. Now, after we tried the fraction form, let's do now the rewriting fraction into decimals. So vice versa. Instead of decimal notation to fraction, this time we'll have fraction to decimal notation. Let's say, for example, we have 43 over 100. Write this into decimal notation. Of course, this is already dividing fraction. We'll do actual division. So this is going to be 43 divided by 100. Okay? So we will divide. Of course, this is not divisible because it's not even 1. So we will add one more 0. So with that, we will already add 0 here and then the decimal point. So this is going to be 4. And then that's 400. Subtract, that's 30. Bring that, add one more 0. Bring it down. You have 300, that's 3. And then that's 300, so 0. Meaning to say 43 over 100 is equivalent to 0.43. Okay? This is its decimal notation of the fraction form 43 over 100. Okay? So, this example, what about you have 501 over 10,000? Of course, over 10,000 because 1 here is in the tens place. There are 3 places of value in the numerator. So that's equivalent to 3 zeros in the denominator. So with this one, what do you think is its equivalent, the equivalent notation or the equivalent decimal notation of a fraction of 501 over 100, 1,000 rather. Okay, 2 minutes. Try and then I'll show the answer later on. Okay, we're good with this one. Oh! I think 1 minute is enough. Now let us write its equivalent answer. Of course, we divide this one, 501. Take this as my scratch, okay? This is 1,000, 10,000. Of course, we add one more 0 here, so that is going to be our... So we're now moving to the decimal part because 501 divided by 1,000 is not possible. So we add one more 0. So 5,010 divided by 1,000, that is 5. Then that's 5,000. So that's 10. Add 0. Add 0 here. So this is 0. Then you have 0. So you have 100. Add one more 0. So this is going to be 1,000. So that's 1 over 1,000. That is 0. So this is going to be 0.500 or 501. 0.501. So this is now the decimal form of a fraction 501 and over 10. Okay? I'm sure you were all able to follow that part because it's just very easy. So we're good with this one. The next step here of our lesson is after writing decimal notation into fraction, fraction to decimal notation, we will now move to round decimals to a given place value. Rounding decimals. Rounding. Okay, for rounding decimals, what's needed here is that we just remember the ruling. I'm sure you know this one, but this is just for the purpose of recall. Okay, let's say for example, we have 6.92 or 9,237 10,000s. Okay, so we have here as our decimal place value. And then say for example, the question here is round it to the nearest thousands place. Thousands place. Okay? Very quick. We will identify where's the thousands place. The thousands place is tens, hundreds, thousands, 10,000. So we're asked now. We will try to round off this decimal notation to until this one. So we're going to remove the 10,000s place. And to do that, okay, there's a ruling that assuming that A here, if A is greater than 5, then add 1 to the rounded place value. The rounded value rather. The rounded value. And then if A here is less than, A is greater than or equal to 5. And then but less than 5, then retain the value to be rounded off. Okay, so where A here refers to the place value to be rounded. Place value to be rounded. So, for example, here, the A is this one. This is the A. And it says round to the nearest thousands place. So, okay. So, that's our A. And then the number, no, let me rephrase that. A here is actually this one. This is the A. The number after the number to be rounded off. So 7. Accordingly, if A is greater than or equal to 5, then add 1 more or add 1 to the rounded value. And then otherwise, if it's less than 5, then retain the value to be rounded off. So this is the number that we have to round off. But since the number after that, the A, is actually greater than 5, it's actually the case of number 1, we will add 3 here with one more number. Thus, this is equivalent to 6.924. Okay? So the rounded value of 6.9237 10,000 into rounded to the nearest thousands place is 6 and 924 thousands. Okay? For this one. Let's have another example. You round off the number, you round off the given place value 3.675849 to nearest 10,000. Okay, the nearest thousands. Okay, thousands. So with that, let's identify what number we're actually rounding this decimal notation. 1, 2, or tens, hundreds, thousands, 10,000. So we're talking about 8 here. Therefore, we will look the number after 8. The number after 8 is 4. And it falls on category number 2 here in our rounding rule. So thus, this is equivalent to 3.6758. We will retain 8 because the number after 8 is actually less than 5. So thus, the decimal notation of 3.675,849 tens, hundreds, thousands, 10,000s, 100,000s, millions. So, this number 3.3 and 675,849 millions, okay, millions as in with th, is equivalent to 3 and 6,758 10,000s. Okay, as we're asked to round it to the nearest 10,000s. Okay, I think we're good with that one. So we're good with rounding decimals. So after rounding decimals, what's the next part? Okay, we will move now to the operation. Operation of operations of decimal. Of course, we will start with additions of decimals. In adding decimals or to add decimals, what is important is we just arrange the decimal digits according to place value. Let's say for example, we will add 237 thousands plus 4.4 and 9 tenths plus 27 and 32 hundredths. Okay, so in adding this one, first step is we will arrange number according to place value. So, again, our first addend is 0.237. Our second addends is 4.9. Okay, we will simply align the decimal point. And then next is 27.32. Okay? That's how we will arrange them, or that's how we arrange place value. Arrange, or we will align the places of value, making sure that the decimal points are all aligned. So then we will add plus. Okay, this is going to be 7. 3 plus 2, that is 5. And then we have 12, 14. Carry 1, then that is 11, 12. Carry 1, then that is 3. Then copy, bring down the decimal point. Therefore, the sum now of these three decimal notation is 32 and 457 hundredths. Okay, this is now the sum. Box it as our answer. Another example. Let us say you have 42.3 plus 162.903 hundredths plus 65.0729. Okay, now this time, I'll give you 2 minutes to get the sum of this one, and after that, I'm going to reveal its solution and how to get the sum of these three decimal notations. So your 1 minute starts now. Okay. 30 seconds more. Okay, I think we're good. Let's solve now. Let's see if your answer is correct for these three decimal notation. So first, our first addend, that's 42.3. And then next, we will align the decimal point. Then you have 162, and then 903 hundredths, and then lastly you have 65.0729. Add, so it's 9, then you have 5, you have 7, you have 12. Since it's 12, carry the next whole to the next whole number, that the ones place in the whole number part. That's 10, carry 1, that is 12, 16, 17, carry 1, and this is going to be 2. So you have 270, okay, copy the decimal point, 270 and 2,759 10,000s. So this is our sum for the 3 addends. Okay, I think we're good with addition. Now we move to the next operation, which is, of course, subtraction. What are the things to remember in subtracting decimals? Wait, before we will move to addition, earlier you saw an example of a number, let's say 215.0975. Take note, 0 here has a significant value. Thus, it takes the place of the tens. Okay? This is significant. The 0 is significant. On the other hand, when you have 25.9750, the 0 here is insignificant. Insignificant. Okay? Because this one doesn't hold any place value, or it doesn't hold any value at all. You can actually remove this one, delete this one. But the zeros here, you cannot disregard this because this 0 here is significant. Meaning to say, there is a value to this, or there is a meaning to the 0 here. But the zeros here is insignificant. Meaning to say, there's no meaning at all. Somehow like your x, there's no meaning at all. Okay? Anyway, that's the kidding part. Let's move to subtraction of decimals. In subtracting decimals, it's very similar to addition. We will arrange the parts of our subtraction, the subtraction equation, according to place value also, aligning decimal point. For example, we are to subtract 21.532 minus 9.875. Okay? So in this case, we are going to subtract this part. So first, we will array first our given, identifying the minuend and the subtrahend. So in this case, this is our minuend and this is our subtrahend. So we have the 21, okay, 21.532 minus, according to place value, that's 9.875. Okay, we have to array them according to places of value. So we will do the subtraction. Of course, 2 minus 5 is not possible. We borrow. This is going to be 12, as this will borrow 10 here. So this is going to become 2, and this will become 4. This will become 12, this will become 14, this will become 0, then 10, this is 1. Okay, 12 minus 5 is 7. 12 minus 7 is 5. And then 14 minus 8 is 2, 6. Then decimal point. 10 minus 9 is 1. Then 1. So therefore, the difference now of the two decimal notation is 11 and 657 thousandths. Okay? So, as simple as that. Let's try one more example. Okay, let's say you have 72.039 minus 8.47. Okay, 1 minute. Solve this one. Okay, so you have 72.039 minus 8 and 47 hundredths. Thirty seconds. Okay, I think we're good now to show our answer for this problem, and then let's see whether you got it right. So let's start. Array first the data, that is 72 and 39 39 thousandths minus 8 and 47 hundredths. Subtract that. Of course, since our minuend in this case is actually the decimal notation in the minuend is until thousands, and then our minuend is only until hundreds, so we'll add one more zero here. Okay, and then we add 1 0 just to make sure that we completely array the decimal digits according to place value. So then we subtract. 9 minus 0 is 9. And then 3 minus 7 is not possible. So we borrow 1. Cancels 1. We will have 13. We borrow the 10 here from the next place value. So this will become 9. As this is also going to borrow from here. So 9, this will become 1. And then this will become 19. As it borrows 10 from the ones place. And then the ones place also, to subtract by 8, then we borrow also 10. So this will become 11. This will become 6. So you have now 13 minus 7, that is 6. And then 19 minus 4, that is sorry. This is not 19, but this is only 9. Because it's from 0 and then borrowed 1, so that becomes 10. And then the 10 was being we borrowed 10 also to the other part, so that becomes 9. So 9 minus 4 is 5. And then the decimal point, 11 minus 8, that's 3. Then 6. So there you go, you have 63 and 569 thousandths. So I really hope so that you guys have tried this one and you arrive with the same answer. Okay? Just in case there are discrepancies, or perhaps something isn't correct in my solution, because sometimes, I'm not too perfect also, and when I'm doing solutions like this one, sometimes there are things that will slip in my mind, and then I come up with the wrong answer. So just comment in the description of this video, so I'll know whether there are things that I haven't performed correctly for the answer. So, but for this, I hope that you arrive with an answer of 63 and 569 thousandths for this one. We are done already with subtraction operation. Let's move to the next and the third operation for decimal number, which is the multiplication. So we will multiply now. Let's say example, multiply 0.3 times 5. Okay, now in this case, in the multiplication of decimals, we don't necessarily arrange them, the place value, but if you can, you just arrange them, but it's not really a must. So we will have here 0.3 times 5. Okay, we'll multiply. 0 times 3, that's 15. Okay, that is, we write here the ones place below and then the tens place above. And then 0 times 5 is 0 plus 1, that's 15. Now, it's important that from the last place value in your product, you will count their place, how many place value equivalent to the place value or the digits in the decimal part. So in this case, we only have one for the decimal part of the decimal notation 0.3. So we will move now. Of course, supposedly the decimal point is here. Since there is one here, we just move it to the left, 1 unit. So since there is only 1 unit in our decimal part, so this is going to be here. So finally, our answer is equivalent to 1.5. So the product of 0.3 times 5 is equivalent to 1.5. Okay? Let's try this one. 21.4 multiplied to 0.36. So we will multiply this one. 21.4 times 0.36. So what do we need to do here is we multiply the numbers as our multiplier. Like I said, it's not necessary to align the decimal point, but if you made, then let it be. So 6 times 4 is, wait, what is 6 times 4? 6 times 4 is 24, so that's 4. Carry 2, 6 times, that's 8, then 8, and then 12. And then 3 times 4, that's 12, carry 1, then that is 3, 4, and then that is 6. Add, that's 4, 10, carry 1, that is 6, 7, this is 7. And then we have how many place value? 1, 2, 3, so that's 3, 1, 2, 3, so we have 7. Okay, finally, our answer is, if I'm going to rewrite it, 7.704 thousandths. So this is now our sum. Okay? Let's have one more practice before I'll move to division. So, let's say you multiply 0.037 times 0.08. Take note, the zeros here, they are significant zeros because there is still a number that are non-zero numbers in the decimal part that is after 0. Okay, in the decimal part of our two decimal notations. So I'm gonna give you 2 minutes. You try to practice this one, and then later we'll do it. We're going to solve it all together, and you better check whether you will also arrive with the correct answer. Okay, I think 1 minute, last 1 more minute, and then we will solve it all together. Okay, let us do it all together, and then you check later on whether you've got also the same answer. So first, let's put it in a vertical manner. So this 0.037, then you have 0.08. Let's multiply this. 8 times 7 is 8 times 7, that is 56. So 6, 5. 8 times 3 is 24 plus 5, that's 29. 9, then 2. So that is 8, 0, so that's 2. Then 0. Then next is 0, 0, 0. And then next is 0, 0, 0. So this is 0 times 7 is 0. 0 times 3 is 0. I will lack one more. Because there are 4 place value above. And then let's add, that's 6. And then there's going to be 9, 2, 0. And then we have 0, 0. And then after that, we will count how many places a value in the decimal part. So, 1, 2, 3, 4, 5. There are 5. So, 1, 2, 3, 4, 5. So, our final answer now is this one. We have 296. How do we read this one? Tens, hundreds, thousand, 10,000, 100,000. So, that means to say we have, this one is written as 296 hundreds, thousands. Okay? So, it's actually 296 hundred thousands. Okay, again, tens, hundreds, thousands, 10,000s, 100,000. So that's why we wrote this one in word form as 296 hundred thousands. Okay, so I think we're good with multiplication. Let's move down now to division of fractions. You know, I'm quite fast with this one with very minimal examples because I know this is just revisiting decimal, operations of decimals. It is not something new, really new to you. Okay, let's do division. And then for dividing, so let's say for example, we are asked to divide 15.275 divided by 3.25. Okay? So we have here 15.275 divided by 3.25. So what we're going to do is first, we will show this one in with our division notation. So that's our divisor. Okay? Divisor. So that's going to be 3. Okay, I'll just do it here. 3.25 with our dividend inside the division operation, 15.275. But in order for us to carry the division operation, we will make the divisor whole number. So we move the decimal point till such time this will become whole number. So 1, 2. So that is equivalent to 2 decimal place value. So equivalently, we will also move the decimal point in the dividend. Equivalent to the places of value, we move the decimal point from the divisor. So 1, 2. It's here. So above here. First, then we will have 325 divided by, of course, 325 is not divisible with 150. So we will go to the thousands place. 300, so that is 3, right? 325 times 3, that is 15, carry 1, 6, 7, then you have 9. Plus 325, that is 10, 9, okay, 1, that's 12, plus 325, that is 0, 11, carry 1, 5, 6. So it's already too much, so we have only 3, 4. Not 3, but this is 4. Okay? 4 times 325 is 1,290. Subtract. That is, this is to carry over division. That is 7. And then 12, not possible, divide minus 9. So borrow 1, that is 12. So this is 3. And then this will become 12, this will become 4. 4 minus 2, that is 2. And then 1 minus 1 is 0. So we have basically already this one. Bring down 5. So since we bring down 5 now, so there is already a decimal point because the 5 here is already a number after the decimal point in our dividend. As we move the decimal point in the dividend into with two decimal places of value. So we will divide now this one by 325. So 300, how many? So 5, I'll just continue this one. This is my scratch. So 325 5, 3, 9, 1. Then plus 325, that is 0, carry 1. 5, 6, 7, 12, carry 1. So 200. So we have 1. Let's try. 1, 2, 3, 4, 7. I think there's something wrong with subtraction. Let's try. 325 times 7. Let's only try if this is going to work. Estimatedly, let's try 7. We divide this one by 7. If we will multiply this one by 7, if we will get we will multiply 325 by 7. Let's see if we will get this number closer to this one, as we will find the whole number quotient. This is going to be 5 times 5, 7 times 7 is 35, so that's 5, carry 3. 14 plus 3, so 7, carry 1. 7 times 3, that's 21, 22. So that's 2,275. Ay, my bad. It's correct. So we have wait, I think there's something wrong with, let's review first our solution. I think there's something bad here. 325 times, we said 4, let's multiply it properly, times 4. That is 5 times 4, that's 20, carry 1. Carry 2. Then that is 8, 10, carry 1. So that is 12, 13. So it's not 1,200, but it's 1,300. Don't know, my multiplication is bad. 1,300. Then we subtract 7. Sorry, let me rewrite this again. 15,275, but the decimal point is already here, so that's why it's aligned there. Let's try to rewrite it again to make it clear. 15, then you have 275. Okay, the decimal point is here, so it's there. 1,300 minus, that is 7, 2, and then it's 2, 0, then bring down 5. Okay, what was that? We tried 7 already, and then this was the answer, right? Let's just show it again. 325 times 7, that is 5, 3, that is 14, 17, carry 1, that's 21, 22. So that's 7, so this is 7, 2,275. Subtract 0. So we have now our quotient of 4 and 7 tenths for 15 and 275 thousandths divided by 3 and 25 hundredths. So the answer is 4 and 7 tenths. Okay, let's have one more example. Okay, one more example. Okay, you divide 0.3 divided to 0.56. So I'll give you 1 minute or 3 minutes first to solve that part. Then after that, I'm going to show the solution. Let's see if you got the correct answer before we'll move to the last topic. Okay, 2 more minutes. I hope by this time you are now finalizing your answer, or what is your quotient for a number of a decimal notation applying division operation of 56 hundredths divided by 3 tenths. Okay, let's try to do it together, then let's see whether your answer is correct. If not, then review your solution, why your answer is not correct. So let's try. First is we will make this into whole number. We move this one place, then one place. So technically, if I'm going to rewrite it, that's 3. I'm just going to rewrite this one to have a more clearer picture of our division. And then this is going to be, of course, the 0 here, as we move it to this one, the 0 here is insignificant. So we can drop that as 5.6. Okay? So 5 divided by 3, that's 1. And then this is going to be 3, 2. Then bring down the next number, which is 6. But the 6 is already after the decimal point, so we place already the decimal point here in our quotient. Now we divide 26 divided by 3. That is, 26 divided by 3. That is 24 is 21. That's 8. And then 24. Subtract, that's 2. Now, we still have a remainder here. We will never write here a remainder, but rather, we can continue until such time that we will be able to remove all the numbers. So, let's add more 0. 0. Here, 20. So, that's 3. That is 6. Then, 18. This is going to become, subtract, that's 2. Bring down 0. You know, the 0 will just, the 20 will just keep on repeating. So, we can write our end here, put a bar here, meaning to say, after that, the 6 will just repeat in the quotient. This is a situation wherein we will have an answer that is 1.86. And then there's a bar here on top, implying that the 6 there is repeated infinitely. So that's going to, once you continue, that's going to be 6 all throughout. Okay, we can just shorten our quotient, written it in this form. Okay? Or, you may write it as 1.87 approximately, as we try to write it or round it to 200ths place. Okay? That is 1.86. Then there's a bar here. The meaning of the bar, again, I said is, that is 1.86666 infinitely. And then, or we can write it by rounding it to the nearest hundreds, which is 1.87 in this form. Okay, either way. Okay, we are good with dividing decimals. You just have to do more practice on your end, investigating what are the possible instances in dividing fraction. Much more with multiplication, addition, and subtractions of decimals. The last part that I'm going to cover here for decimal is we are going to compare now, comparing converting fractions and decimals. We will start with, we will convert 3/7 into decimal. So basically, to convert this one, convert to decimal. Okay, sorry, it should be fraction to decimal. So what we're going to do here, we divide 3 divided by, sorry, 3 here is the dividend and 7 is the divisor. So that's 7 divided by 3. Of course, that's not possible. So we add 0. So since we add 0 now, then that means to say there is already a decimal point. Because this fraction here implies that this is less than 1. Thus, our quotient is actually less than 1. So 30 divided by 7, that is 9. Then that's 27. Then there's 3. Add 1 more 0, 30, that's 9. And then, after that, add 3. Ay, sorry. I'm thinking about 3 when 7 is our divisor. My bad. Let's do it again. 30 divided by 7 is 3. Sorry, it's 4. And then it's 28. That's 2. Add 1 more 0. Then bring it down. 20 divided by 7, that is 2. Then that's 14. That is 6. Then bring down, add 1 more 0. 60. That is 63, the 9. Then that's minus 7. 63 minus 7. 56. That is 6. 56. Okay. Subtract, then that is 4. So we can just end here. Anyway, the point here is we'll just end until hundreds place. Normally, numbers here, answers are being rounded to 2 decimal places only, or until the hundreds place. So, or approximately, this is written as 0.43. Okay, as we round out to the hundreds place, more or less. So, the converted 4 or 3 over 7 is approximately 0.43. Because more or less, this one is an irrational number wherein the decimal point will never stop. It will continue. Okay? So that's how we do the conversion. What about if we convert 3 and 4 or 2 over 9? 3 and 2 over 9. What is its converted form? And then, okay, convert to decimal, and round answer, round to the nearest tens, nearest thousands. Why this is so, or this was being rounded to the nearest place value? Because normally this is, the numbers here are infinite, or rather there are irrational. Meaning kasi the decimal point will never end. So if you're going to do the division here, carry over division, and not identifying to round up answer to a certain place value, then you are not going to stop. You're not gonna end with your solution, because that will continue. That will keep on and on, because the division operation here will never stop, since the answer here is since the number is irrational. So what we're going to do is, first we will rewrite the number into improper. So 9 times 3 is 27, plus 2, that's 29. So 3 and 2 over 29 is equivalent to, or 2 and 2 over 9 is equivalent to 29 over 9. And that's what we're going to divide now. That is 29 divided by 9. Of course, 29 divided by 9 is 3. 27. So there's a remainder of 2. And then add more 0 here. So since I added 0, then there's already a decimal point. Add. So that is 2. 18. So there's a remainder of 2. Add more 0, that's 2. That is 2 here, then that is 18. 2, 0, 0, that is 2. Accordingly, until thousands place tens, hundreds, thousands, so we need one more. 18, then 2, add one more 0, 0, so this is 2. Rounded to the thousands place, so that's approximately 3.222 as our quotient. Why we end until thousands? Because that's what is instructed to us. We convert the mixed number into decimal with an answer rounded to the nearest thousands. So we end up with a quotient of 3 and 222 thousandths. Okay? What else do we got here? We will do the reverse. This is fraction to decimal. Now let's move to decimal into fraction, converting and then comparing. I mean, we are still doing the conversion. Later we will do the comparison. Comparing decimal and fraction, which one is greater. So next here is decimal. Let's say 0.82 and then let's convert this into decimal. Of course, this is 82 over 100. But of course, this must be reduced to the lowest term. So, okay, let's try to look for a greatest common factor between 82 and 100. So that's 82. The factors of 82 is divided by 2. That's 2. 82 divided, that's 41. 41 here is prime. So we have now the prime factorization of 2 and 41. And then what 100 is equivalent to 2 times 2 times 5 times 5. We lack one more 2 times, sorry, it should be 2 times 5 times 5, because 5 times 5 is 25, times 2 that's 50, times 2 that's 100. And then the greatest common factor is actually 2 here. Therefore, we will divide this one by 2. Divide this by 2. We will get now 41. And then that is 50. So we have now the equivalent of 0 and 82 is 41 over 50. Now on your example, for your example or practice, you convert 4.75 into fraction, okay? Giving you 2 minutes. Try to convert 4.75 into fraction form. Okay? So, we're almost done with our discussion. After this example, we will just do the comparison or the comparing and then we're good. 4 and 75. 1 more minute to go with your own exercises or your own example. Okay, I think we're good. Let's try. So, writing this one into fraction. This is going to be 4 and 75 over 100. But of course, reduce this to the lowest term. That's 4. Greatest common factor here is 5. Or rather, 25. 75 divided by 25. That is 3. And then this is 4. So you have 4 and 3/4 as our converted form for this one. I hope and I congratulate for those whoever got the same answer with whatever is the answer here. Congratulations if you got it right. one last example or one last part of our discussion this time is we will do comparison. We will compare which one is greater or less than between fraction and decimal. Let's say, for example, let's try to compare um, 5/16. Let's compare to 0.32. Which do you think is greater? So you have two ways to do it. It's either you make 0.32 into fraction, and then which one is greater, compare it, or you will convert the 5/16 into decimal and then compare. So it's up to you. But whichever is possible, then you do it. So what I'm going to do is I'm going to rewrite this or look for its equivalent. 0.32 is equivalent to 32/100. But this isn't in the lowest term. So let me try to reduce this to the lowest term. Divided by 2, that is 15. 16/50, still divisible by 2, that is 8/25. Of course, 8/25 is no longer reducible. So if I'm gonna compare now 5/16 and then 8/25, cross product, 5/25 is 125. Because remember, 5 cube is 125. Compare that one, that is 16 times 8, that is 6 times 8, that's 48. And then that's 8, 12. So 128. So you notice this one is greater. In other words, okay, since 125 is less than 128, which is in favor to 1/25, therefore 0.32 is greater than 1.16. Okay? Example. Let's have one more example. Let's compare 0.63 and compared it to 5/8. Which do you think is greater between the decimal notation and the fraction? So, what I'm going to do now, 0.63, I'm going to convert this one into fraction. That is 63/100. Okay, because 2 decimal place value. Now, this is no longer reducible for they don't have any in fact, with reducing to the lowest term, since our purpose is just to compare them, it's not really necessary. Anyway, we have like this one, you just do the cross product and look for which fraction is greater. So we have 63/100, and then you have 5/8. Cross product, 63 times 8, that is 4 to 48/50. So 500. 4. And then this is 500. So clearly 504 is greater than 500. Therefore 63 here is greater than 5/8. Okay? So that to wrap up our discussion, this part is simply just recalling decimal number, and then mostly decimals are being encountered whenever you do or when you purchase items or for prices. One just last parting point about decimal. Why do you think when items are sold or sell, they end up or they normally have decimal parts or decimal notation or digits? What for? Why do you think merchandiser do not sell products at an exact amount? For example, instead of selling, for example, a slip-on, a slide Adidas sleeper or footwear rather, so is sold for, for example, 999.99. Why there is 0.99 and why not make it 1,000? Or say for example, you're buying a biscuit of 197, a box of biscuit of 197.35. What's the 35 for? Why not make it like 200? And why they normally or they usually have the decimal parts of the price of the item. You know why? It's sometimes it's marketing strategies. For example, the 999.99. Why not 1,000? Because sometimes they try to lure the customers thinking that, oh, this one is way cheaper because it's not yet 1,000. Where in fact it's the value of it is just 1,000. How would you even get a change of 0.01 or 0.001, or rather 0.01 as your change when you purchase that item with 1,000? But that is just a marketing strategy, trying to convince the consumer or the customer that the items sell now is uh, cheaper for it's not yet even 1,000. So in short, it's just marketing strategy or technique. So anyway, that is the wrap up the discussion. And then I just hope so that you learn something with our discussion today. You can go over with our video available in my YouTube account. I'll just provide you the link. And then just keep reviewing, try to review it over and over again in preparation for your activity tomorrow, your asynchronous activity for tomorrow. So with that, class, thank you so much and bye. I hope you enjoyed the day, and then be ready for the quiz tomorrow. Again, please remember to read and follow instructions for our quiz. So bye for now and be safe, everyone.